All right, here we go with example 3 on Tuesday, January 12th, 2021. Charge Q1 has a value of positive 4.50 microcoulombs. Located a distance of 3.60 meters to the right of it, charge Q2 has a value of 6.90 microcoulombs. Going an additional 4.70 meters to the right of charge Q2, charge Q3 has a value of positive 4.00 microcoulombs. As before, calculate the net force on Q1, the net force on Q2, and the net force on Q3. Okay, trying to go over what the forces are individually. So between charge Q1 and Q2, I would type into my calculator Boltzmann's constant, lowercase k, times charge Q1, which is 4.50 times 10 to the negative 6 power coulombs, times charge Q2, which is 6.90, again, times 10 to the negative 6th power coulombs. That's what micro means. Divided by the distance between Q1 and Q2, a value of 3.60 meters squared. K, whoops, let me clear things out. K times 4.50 times 10 to the negative 6 times 6.90 times 10 to the negative 6 divided by 3.6 squared. Enter. Yeah, I'm getting a value of 0.0215 newtons, and that is a repulsive force. All of these are going to be repulsive because all three charges are positive charges. All right. So to calculate the force between charge Q1 and charge Q3, here's some student speculations. I'm going to do it now. So I'm typing into my calculator K times 4.5 times 10 to the negative 6 times 4 times 10 to the negative 6 divided by, and I'm going to go open parentheses, 3.60 meters plus 4.70 meters, close parentheses, squared, enter, and I get not this, not that. I get 0.00235 newtons. 0.00235 newtons. For the force of attraction or repulsion between charge Q2 and charge Q3, into my calculator, I would type alpha K times 6.90 times 10 to the negative 6 power times 4.00 times 10 to the negative 6 power divided by 4.70 squared. Enter. And my results agrees with this student. 0.0112 newtons. And calculate that in my case, I got a result that the net force on Q1 is 0.0239 newtons, pushing it to the left. For the net force on Q2, I get 0.0103 newtons pushing to the, now let's think about this. So the one that goes to the right is stronger than the one that goes to the left, so this goes off to the right. And finally, for the last one, I got a value of 0.0136 newtons. And of course, both of these are pushing it to the right. Didn't have time for students check my work on this time, but this is my result for example 3.